Okay, for this video for all things graphs, we're just going to work through the first example together in the notes and then keep up with this piece of paper because this is going to then be your assignment tomorrow. The first one doesn't have anything to do with rationals, but it does have to do with some things I want to review and just some key concepts of piecewise functions and then also transformations, just kind of a review of all that. And then you can even see on this worksheet that it does get into some rationals as well with some of the other examples. Okay, so we'll work on this in class. So as you have questions, just ask or work on it with someone near you. Okay, so first we're just going to graph the function. Then we're going to take absolute value of the whole thing, which we know how to do. Then we're going to do just a simple, not from part B, but part C is just of part A. Just a simple shifting left 3 and up 2. Okay. Each of these things are independent. I guess B and C are dependent on A, but C is not dependent upon B necessarily. Okay. So on number 1, when we're graphing this parabola, the first thing we need to do is to complete the square. Okay, so let's do that. And I'm going to do this on a separate sheet of paper, or separate slide. Okay, so I have y equals negative x squared minus 2x plus 3. Let me just do a quick check to make sure that was right. Yeah. All right, when you're completing the square, there are different methods here, okay, but the way I've been showing it in my video lessons is to move that plus 3 over. Here I have to factor out the negative x squared, or just the negative, sorry. That's going to make that plus 2x. You're going to take your 2, going to half it, box it, square it. So plus 1 completes the square. What I really did, though, is a negative 1. So I can either do a negative 1 over here, or I can do the opposite, which is a plus 1 over there. And you get y equals negative x plus 1 squared plus 4. At this point, everybody should be able to do that error-free every time. Okay. Oops. So I'm going to write this above here. Y equals negative x plus 1 squared and then plus 4. So when we're graphing this parabola, remember the vertex is at negative 1, 4. 1, 2, 3, 4. Okay. And this just has a vertical reflection, but the shape is not changing. So I'm going to go, would normally go over 1, up 1, but I'm going to go over 1, down 1, both sides. Over 2, down 4. Another way you could find these points is just a T-chart. Okay, I could continue to go over 3, down 9, but, and I will actually in this case because of where this graph stops. I do need to know what is f of 2 in this case. So if I went over 1, 2, 3, down 1, 2, 3, 4, 5, 6, 7, 8, 9, that's at negative 5. And you could also find f of 2 to figure that out. F of 2, whether plugging it in the top or the bottom, you will get negative 5. Okay. Then I'm also going to reflect this point over here. It might as well be as accurate as you can be. And then I'm going to stop right there. Okay, so now let's do the absolute value transformation. I always have students ask me, how do I know this is not just the absolute, is this the absolute parent function or is this the absolute value transformation? It doesn't really matter. You could do it either or. You can think of this as linear parent function and then do the absolute value transformation, or you could do the absolute value parent function. Since we haven't practiced this as much, let's do the absolute value transformation, which is just the v with a slope of 1 and negative 1, and then this is shifted to the right 4 and down 3. So 1, 2, 3, 4, down 1, 2, 3, and the v is going to go up 1 over 1. Same thing here. Now, right here, I'm going to stop just short and write an open circle. Okay, and you can check this. Even though f of 2 equals negative 5, because I plugged it in this top part, you can plug a 2 in right here. 2 minus 4, that would be negative 2. Take absolute value of it, get 2. And 2 minus 3 is negative 1. So you can know that you plotted that point, even though that is a hole. All right, so this is my piecewise function. Notice that it's a function. If it's not a function, if it fails the vertical line test, you need to go back and redo it. All right, let's do part B, which is taking absolute value of this whole thing. Now remember, when you take absolute value, the parts where x are positive stay the exact same. All right, so I'm going to redraw those. 1, 2, 3. Okay, that stays the same. Okay, likewise, there was 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, that stays the exact same. The only thing that's going to change are all the places where y value is negative. Okay, so let's start with this parabola. This point, which was 5 below, is now going to be 5 above. Okay, same thing over here. Okay, this v, this absolute value, is all going to be reflected above. The y values that were negative now are positive. So our vertex was at 4, negative 3. Now it's at 4, positive 3. Okay, now when we do part C, it has nothing to do with part B. We're going to look at the original function. We're going to shift it to the left 3 and up 2. Okay, so I'm going to take that parabola. It was at negative 1, 4, and I'm going to move it left 3. So let me get my bearings. Here we go. Left 1, 2, 3, and up 2. Well, I lost it. 1, 2, 3, 4. Okay. It's a lot easier to do on paper than an air slate. 1, 2, 3, up 2. Okay, there we go. Over 1, down 1, both sides. Over 2, down 1, 2, 3, 4, both sides. And when you shift this over, we are going to shift everything, including where this graph ends. Okay, so this point that was down here, we're going to move that. It's just going to be this graph in part A under these transformations. Okay, so I am still going to go over 3, down 9. So 1, 2, 3, 4, 6, 7, 8, 9. Okay. Now this this point right here that was at 2, negative 1, it's going to go over 1, 2, 3, up 2. My vertex, which was at 4, negative 3, over 3, up 2, and there we go. Okay, so that was just a kind of a review of piecewise functions, parabolas, absolute value, basic transformations, and the absolute value transformation. On the other problems, you're going to have to do this with rationals as well. But I'm not going to give you the hardest rationals possible, okay? So, but you will have questions, okay? So don't hesitate to ask those questions.